Now our experiment is ASTABLE multivibrator using 555 timer IC. The aim of experiment is to verify the operation of ASTABLE multivibrator using 555 timer. Now let us see the circuit diagram. Required components are resistors, 2 resistors 3.3 kilo ohm and 3.9 kilo ohm, capacitors 0.1 microfarad and 0.01 microfarad, CRO, DC power supply and a diode and a 555 timer. There are 4 cases in this experiment. First one is unequal resistor without diode and equal resistor with diode and equal resistors without diode and equal resistors with diode. Now let us consider the first case, unequal resistors without diode. VCC is given to the 4th pin and 8th pin, and with by using 3.3 kilo ohms it is given to the 7th pin, and 6th pin and 2nd pin are shorted, and between 7th pin and 6th pin we have connected 3.9 kilo ohm resistor and a 0.1 microfarad capacitor. Now a 0.1 microfarad capacitor is grounded from 2nd pin to the 2nd pin, and 1st pin is grounded, and 5th pin is connected to ground by using 0.1 microfarad, and at the 3rd pin we see the output, and at the third pin we get this output, and at the 6th pin we get this output. This is the 555 timer IC, and there is a notch here, and at the notch this is the 1st pin, 2nd, 3, 4 followed by 6, 7, 8. While placing IC, ensure that you have placed it middle of the breadboard, and this is the notch here, there is a notch here, and this is 1, 2, 3, 4, 5, 6, 7, 8 pins. And from the circuit diagram, now let us connect this. First pin is grounded, and a 0.01 microfarad capacitor is connected to the 5th pin and the ground. Now VCC is given to the one of the rows of the breadboard, and from that 8th pin is directly connected to VCC, and 4th pin is also connected to VCC, and now 3.3 kilo ohm resistor is connected from VCC to the 7th pin, and a 3.9 kilo ohm resistor will be connected to the 6th pin from 7th pin and 6th pin. That 3.9 kilo ohm resistor can be connected for a 6th pin or 2nd pin, because 6th pin and 2nd pin are shorted, so we can connect between 7th pin and the 2nd pin, and from 2nd pin we will connect 0.1 microfarad capacitor to the ground. Now we have connected the capacitor to the ground. Now let us take the output. We take the output at the 3rd pin, and we have connected. So we will give this to the CRO, and we also take output at the 6th pin. This is the output at the 3rd pin. It is a square wave, and now let us calculate the on time and off time of the square wave. Now let us calculate the on time and off time of the square wave, and this is the on time of the square wave and this is the off time. So T on equal to it is approximately 2.6 and 2.6, and it is 0.2 milliseconds. So 2.6 into 0.2, and now T on is 0.52 milliseconds. Now T off. So by adjusting we will find the T off. So it is nearly 1.4 into 0.2, it is 0.28 milliseconds. So we'll write this T on and T off in the observation table. And now let us consider the output across 6th pin. Output across the 6th pin. So output probe is changed to the 6th pin. When we see the output at 6th pin, we have to change the mode into AC mode, and this is the wave, and from here to here it is the TC, and from here to here this is TD. By calculating TC, it is nearly 2.6, and 2.6 into 0.2, that is a TC, and we can see the TD by shifting the wave. It is nearly 1.4. So by that we can calculate the TC and TD of the output at across 6th pin. And VP and VV. VP means peak voltage and VV means value voltage. Peak voltage is the voltage from this VP means it is the voltage from zero level to the peak level. So here it is 1.6, and from in channel 1 5 volts, so 1.5 into 5, and it is nearly 8, and this is the value voltage. By adjusting it we can calculate the value voltage, and it is nearly 0.4 into 5, it is 0.8 into 5 volts, it is and it is 4 volts. So here we calculated VP and VV, TC, TD. So this T is TC plus TD, and frequency is 1 by T. Duty cycle is T on by T on plus T off. So T on is TC, T off is TD. So T on by T on plus T off into 100. By calculating that we will get the duty cycle. Similarly, we will do all the 4 cases without diode, equal resistors, with diode and unequal resistors, with diode and unequal resistors, with diode and equal resistors.